Hello students, this is Kumar Yadvinder and welcome to the TachyLab. Today we are going to start with the unit force and motion. And in that we are starting with the topic movement and position. So in this lecture we'll be discussing about the distance and displacement. But before moving into that topic, we need to learn about a few basic things. So here we go. Let us learn about the rest. So when do we say that the object or the person is at rest? Have you ever thought? How do you actually define it? Let us take an example. Suppose if this is a person, right? The person is sleeping and it's been like you come after 5 minutes, the person is sleeping. You come after 15 minutes, the person is sleeping. So you say that, okay, the body is at rest. So how do you define it? Because the position isn't changing with time, right? At t is equals to 0 second, the position is suppose A or any. Let us say in this case it's bed. You come after 5 minutes, again it's same. You come after 15 minutes, again it's same, right? If let us say this is the position A and it's just not changing, it's same. So when the position does not change with time, we say that the object or the person is at rest. Then comes motion. So how do you define motion? See, everything around us is in motion. You look at the birds, you look at the fishes, the trees, their leaves, the cars, even the blood which is flowing in your veins, even that is in motion. The planets itself, even if you say that, okay, you're not moving, but if you look at a bigger picture, the planets, our solar system, everything is in motion. And not just that, the air that we are breathing, the gas particles, they are in motion. I know this is a ridiculous example, but yeah, let it be. But yes, the gas particles are also in motion. They are also moving in this zigzag random motion. So how we can define it? Let us take an example of a car. The car is moving, right? But how do we say that, okay, at time t is equals to 0 second, the position is A. You see, after 5 minutes, the position is B. So it has moved, it has changed its position with time. It's not at the same location. So when the object changes its position with time, we say that, okay, the body is in motion, right? Then let us see what is reference point and origin. See, any kind of point that we are deciding and we are telling the location, compared to that point, that is our reference point. In this scenario, let us say this person, it is at position A, right? So in comparison to this person, the house is 300 meter, market is 1.5 kilometer, right? The school is, let us say, again 1.5 kilometer. So if I have to say that, okay, what is the location of school from market? It will be 1.5 plus 1.5, that is 3 kilometers, right? Because in that scenario, the reference point is the market, okay? All these distances which are given here are considered, like the reference point is considered to be this person, right? Then comes origin. So on the coordinate scale, the 0 point, okay, that we call as origin, okay? So here we can say that, okay, where is point A? The point A is 60 units. So here the reference point is basically this origin, okay? It's the coordinate system, the number line that we usually take, okay? B is 35 units and C is 25 units. I hope this is clear. Now we will start with our topic, that is distance and displacement. See very carefully. We will understand with the help of an example. As usual, we have home and we have school. We have to move from home to school. There can be so many ways, so many paths that you can take, correct? So from home to school, let us say this is a straight path, right? This is path 1, 2, 3, 4, 5. And in first path, let us say it is 2 kilometers. But in the whole path, the direction remains same, that is east. It's not changing. It is defined, right? While if you see the second one, this is the direction at this point, this is the direction, at this point this is the direction. If you look at third, this is the direction, at this point this is the direction, again it's changing. In fourth, it's a curve, so at every point it's changing. At 5, it's firstly towards south, then east, and then north. Again, throughout the path the direction is not same. So it is only first path, which is also the shortest path between home and school, which is a straight line, right, in which you can define the direction. Otherwise, all you can give is the magnitude, that okay, this path is like 3 kilometers long or 6 kilometers long or 2.5 kilometers long or 2 kilometers long. You are not able to define direction in all of them except for the first one, right? So distance is the actual path. This is distance. But when we talk about the shortest path, that is displacement, which is usually a straight line, right? So this is the total path length and this is the shortest path between the initial and final points. Then comes scalar and the vector quantities. So whenever we have some quantity and you're telling only magnitude of that quantity, then we say that okay, it is a scalar quantity. But if it also tells direction, like 2 kilometers east, east is a direction, that means it's a vector quantity. So distance would give us only the actual path and not the direction, so it's scalar quantity. Displacement will give us the magnitude but will also give us the direction like north, east, west. Then it's a vector quantity. Now distance can always be positive or zero. Okay, like if the body hasn't started moving, we say that okay, the distance covered is zero. Otherwise, once the body starts moving, the distance will keep on adding up. But if you look at the displacement, it can be positive, it can be zero, and it can be negative. So if the body is moving, like let us say straight, so it's positive, right? If it comes back to the same point, it will be zero because the initial and final points are same. And suppose it again starts moving, when it was moving backwards, then we take the distance as the negative, right? Let us say this is point A and this is point B. So from A to B, person covered 5 meter and then it started returning back to C. Let us say this is 2 meter, right? So what is the displacement? So the displacement would be 5 minus 2, that is 3 meters, right? So in this, the 2, so it is basically 5 plus minus 2. So we are taking it negative, okay? So when the direction is opposite, then we say that okay, it's negative. I hope this is clear. So the distance depends upon the actual path that we have taken, while displacement does not depend that okay, what path are we taking or how are we taking. It only depends upon the initial and the final position. Suppose even the body has covered this path, but if they ask you for displacement, it's nothing but this straight line. You just have to calculate this straight line. Let us do a question now. Okay, so during a sports day, Alex starts from point A, bottom left corner. The court measures approximately 28 meter in length and 15 meter. Okay, this is 28 meter, this is 15 meter. 28 meter, 15 meter. It says using the diagram, answer the following questions when the Alex walks along the edge of the court from A to B, A to C, A to D and A to A. So we have to calculate the distance and the displacement, right? So let us do one by one. Now A to B. So when the Alex is moving from A to B, distance is equals to the length of the AB, which is 28 meter. And if we look at the displacement, so the shortest distance is the straight line and AB is a straight line here. Again, it will be equal to AB, that is 28 meter. Now coming to the next part, that is A to C. Now, A to C. When we talk about distance, distance is the actual path. This was 28 meter and this was 15 meter. 28 meter, 15 meter. So the actual path is 28 plus 15, that gives us 43 meter. But when we talk about displacement, it is the shortest path. So the body actually, or basically Alex, has moved from A to B to C, but when we talk about the displacement, doesn't depend what path the Alex has taken. It just depends upon initial and final points. So it will be equal to the diagonal. So we will use the Pythagoras theorem to find it out. Okay. So displacement is equals to AC, and AC is equals to AB square plus BC square whole under root. So AC comes out to be 28 square plus 15 square. So it is 784 plus 225. So AC comes out to be 31.76 meter. This is the displacement. Then comes A to D. Now the Alex has reached this point. Okay. So distance is the actual path, which is 28 plus 15 plus 28. It will be 71 meter. And what about the displacement? That is equals to AD. The shortest path between A to D point is AD, which is nothing but 15 meter. Then comes A to A. So it is A to B to C to A. So distance is equals to 28 plus 15 plus 28 plus 15. So it adds up to 86 meter. But what about the displacement? Yes. So A to A, initial and final positions are same. The beginning and the ending is the same. So what will be the shortest path? Nothing. So it will be 0 meters. So displacement is 0. So from this question itself, we can draw actually two things. Okay. Now what are those things? Just look at the values here. In this, distance and displacement are equal. Now A to C, distance is 43 and displacement is 31. So distance is greater than displacement. If we look at A to D, again distance is greater than displacement. While A to A, again distance is greater than displacement, but the displacement was 0. Correct? Also, if you're liking the video, you like the explanation, you are able to understand the concept easily, do like the video, subscribe to the channel and share it with your friends. Free notes will be available in the description box. You can go and check. Also, we provide one-to-one private classes and small groups classes. So you can contact to have more details. So yeah, let's just move to the conclusions now. Now, what are the conclusions? Distance is always greater than displacement. Okay. So we can say distance at max can be equal. So distance is greater than equal to displacement. Okay. This is important. Then whenever the initial and final points are same, you don't need to think anything. Just put displacement equal to 0 whenever the initial and final points are same. So here's another question. An object has moved through a distance. Can it have 0 displacement? If yes, support your answer with an example. So we have just discussed about it, right? So yes, the object, first of all, you have to tell, can you or can it happen? Yes, it can happen. How it can happen? The object can move through distance but still have 0 displacement if it returns to its starting point. Then let us mention the example. Mention any one example. Okay, you can make any example on your own also. Here I have written 2. A person traveled 2 kilometers to market and returned back 2 kilometers. So distance covered is 4 kilometers because 2 plus 2 is 4. But since the initial and final points are same, the displacement is 0. Same way if the person moves in a circle of unit radius. So in this case, let us say it starts from A and it ends at A. So what happens here? So the distance is equals to circumference, that is 2 pi r, which is 2 pi meter, while displacement will be 0. Why? Because initial and final points are same. Well, thank you so much for watching, and I'll see you in the next lesson. Until then, keep learning, keep practicing, and have a wonderful day.